Another very important question which we need to discuss concerning the Sentinel Hub or browser is actually what satellite data to choose in that browser to find, and how generally the satellite images from different satellites differ from each other. And in Sentinel Hub browser, so remember at the step 2, we have to select the source of our satellite data. There are actually a pretty long list of data sources available. By the way, there are not only satellite images here, but also some data derived, some spatial data derived from it. For example, with DEM, it is a digital elevation model. Actually, the map showing you altitude of your location. It is produced using satellite images, but it's by itself, it is not a satellite imagery per se. So, what satellite to choose from the list? So just click the question mark next to every satellite to learn about the key features of each imagery type. And the most important features are the spatial resolution, the revisit time, and the data availability. And you could read about all of them clicking this question mark next to every satellite and data type in the list. So just learn about these key characteristics of a particular satellite data, and let us go a little bit deeper into that. First of all, the spatial resolution. Here in that image, the concept of it is presented, how a particular workplane looks like, or could be look like in the image at different resolutions. So the resolution is basically the size of a pixel in the image, and depending on the size of a pixel, you could see some details or not. For example, even at the coarse resolution, you could recognize that this is a plane, but cannot see any details. You cannot identify the type, for example, and at even coarser resolution, you will not even see, and you will be not able to understand, is it a plane or what is it? What's it? But of course, in most cases, we deal not with planes, but with some even more coarser and larger objects, like trees and forest and other landscapes and large buildings and the top areas. And actually also the level of details you see depends on the spatial resolution. Spatial resolution is somehow a projection of a pixel on the ground, and it just is related with the area covered with that single pixel. If a pixel is small enough, like in that image of high resolution from QuickBird satellite, so you could see every single tree in the forest, and sometimes even branches of the forest. Is a size of a pixel is smaller than the size of, or comparable with the size of a tree crown. But if your resolution of your images is sufficiently smaller, then the projection of every pixel on the Earth will cover not a single tree, but a group of trees in the forest. And then it means that it will somehow show us the average characteristic, average intensity of light reflected from different tree species. For example, it will be a mixed signal from coniferous trees, deciduous trees, and sometimes you could think that it is maybe not very good. It would be better to see particular trees, every particular tree separately, but in reality, usually you do not need that level of details because it is much more important to see somehow how it is called, to see the forest behind the trees. So to see the characteristics of the whole forest tract is quite often more important rather than to see every individual tree. And these medium resolution images are the most useful for that. That's just an example. For example, this is a screenshot from Google Maps. And in the Google Maps for big cities and for populated areas, we have usually very high resolution images. So you could see here a particular park in the city of Moscow, the capital of Russia. And you could see that in Google Maps, you could see really detailed images. You could see not even a single tree, but also every big enough branch of every tree. But this in a red squares here is a projection of Landsat satellite, 30 by 30 meters. So the spatial resolution for Landsat satellite is not so high. So you will see that inside every of these 30 by 30 meter pixel, usually a few trees will get, and the signal will be somehow generalized, and, or will be like an average of reflectance of light from a few different trees. And the yellow square is the pixel of Sentinel-2, and also it is smaller than for Landsat, that you could see more details with Sentinel-2, but still it will be some generalization comparing to these high resolution images usually available in Google Maps. And this is just an example of Sentinel-2 image for the same area. So comparing to this detailed picture, you will see only very generalized picture. You do not see any particular tree here, but still you will see some open space in the right lower part of the image. You will see domination of coniferous species in the upper part, and you could see some more deciduous trees in some other parts of the image, and that resolution is enough for that. And here it's even coarser resolution of Landsat 8. Still, you cannot see much details, but still you could see the general tick species composition for that forest. You could see that some built-up area in magenta is bordering this forest tract from the south. Actually, the spatial resolution could be very different. This is one of a possible classification. Usually when we are talking about very high resolution, it's about images with a pixel size less than 1 meter, currently up to 25 centimeters per pixel could be available. And Landsat and Sentinel are regarded today as medium resolution satellites from 10 to 30 meters pixel. But there is also many satellites with even coarser resolution, which could be used for other purposes like clouds monitoring, weather prediction, sea and oceans monitoring, and many other useful and very important things. So if we will learn about the spatial resolution, that none of the imagery actually available via Sentinel Hub, your browser, has as high spatial resolution as the images you could usually see in Google Maps for populated areas. So all of this data, smaller or coarser resolution, but still they could be very, very useful. The highest resolution available is 3-4 meters per pixel. We have these planet images, but they are available only for tropical areas. And what we imagine with global terrestrial coverage, the highest resolution we have Sentinel-2, and also Landsat 7, Landsat 11, 8, and 9 images. We have 15 and 30 meters per pixel resolution. Actually high enough for most of the purposes of monitoring natural objects and changes in the landscape or in the built-up areas. So still very useful and important. This is images I was talking about. This is just to compare here. This is an example of very high resolution images, even better than in Google Maps quite often, where you can see particular cars, particular trees and branches and persons walking. This is an example from the image from Sentinel-2. And this is exactly the same area in Moscow we have seen these examples, and we in the center these two red squares. You can see these are the pixel projections of two Landsat images, and this is the area we have seen at high resolution a few slides above. So you could see that you cannot see single trees, but still you could see much more detail, much more other details. For the whole area, you could see generally the species composition, you could see built-up areas, you could see roads, you could even see cars in the roads, and you could see some crop fields and parks and lakes and other areas, other land cover types. And this is also Landsat 8 image, also for the same area. Again, you do not see much details here, but you could see a lot of beautiful information for the whole area at a bit lower scale, but you could identify here the boundary of the park, the boundary of the built-up areas, industrial areas, living zones, croplands, wetlands, conversion decidual forest, and waters, turbid water and clean water, and so on. At some even coarser scale, you quite often could not see much details, but still you could see the general large land cover masses like big forest tracts, big rivers, some massive tracts of croplands, or big enough grass fires, for example, the fire scar. You could see the black here in the bottom of this image. You could see the footprint of a wildfire, which is big enough to monitor, and many other stuff. And also some images could have pretty coarse resolution. Like, for example, this 1 kilometer resolution image. Every pixel has a size of just 1 kilometer on the Earth surface. But at the same time, it is very useful to monitor the atmosphere, the clouds and movements. And here you could see, for example, the whole Eastern Europe from Black to Baltic Sea. And you could see the cyclone and could predict how it will move and what the weather will be in different parts of the continent. And finally, at very, very low resolution images, you could see even the whole Earth at once. Of course, you will not see any details, but still you could see, for example, the atmosphere movement and some important phenomena on seas, etc., etc. Okay, another key feature of every imagery is very visit time. Actually, how often the same time was shooting from the same satellite, how frequently you could monitor your area. And actually, most of the satellites, as you could see, are not very frequent. Basically, especially if you're talking about high resolution satellites, they do not shoot every area regularly. They only could do some shooting to request, And if you remember images available on Google Earth, for example, you could learn that for any selected area, in the best case, you could have a few images per year. So it is impossible to find high resolution images like every day for the same area. Usually nobody does it, only sometimes for military purposes. But basically, also for the large areas, you hardly will find very frequent images of high resolution. And other images could, like Landsat, for example, 8 or 9, they could cover, or 7, they could cover the same area again in 2 weeks, even more than 2 weeks, in 16 days. And of course, because we are free satellites, you could get some more frequent coverage. Sentinel-2, for example, there are 2 satellites of that type operating, and so every satellite could cover once in 10 days, where visit time is 10 days, and for 2 satellites it could be 5 days. So we could find pretty many satellites. At the same time, many not very high resolution satellites, not very detailed satellites, could cover the whole area virtually every day, or sometimes even a few times a day. So this is very important for monitoring purposes. And what it depends for? It depends primarily on the, of course, the equipment on the satellites, particularly on the source white, the white of a stripe being shot in by satellites by flying color. And usually this white of this stripe could be very differently, could be very white at some satellites, like Terra and Aqua satellites, equipped with MODIS sensor, with MODIS camera, which has this swath wide over 2,000 kilometers, so they could shoot huge area at once. While, for example, Landsat only could make an image with a wide 185 kilometers. And so this, of course, results in different productivity of the satellites. For example, this coverage of the whole continent of Eurasia by a single satellite just at one day. So you could see that in one day, the satellite could shoot huge areas. And actually, this is usually a compromise between the resolution and revisit time. Let's say between spatial resolution and temporal resolution. For example, here you have the satellite coverage from Terra satellite for one day, which covered virtually the whole year, excluding Antarctic, because of polar night there at the shooting time. And 2 satellites, Landsat 7 and Landsat 8, at the same day, they only produced that thin stripes of satellite coverage for the whole Earth. So they together will need more than a week to cover whole terrestrial areas of our planet. So this is usually a compromise, and we should keep it in mind. But looking at the very high resolution images, you should be aware that it is impossible to shoot them very frequently. Yes, and if we will just discuss about revisit time, but actually this Sentinel-5 MODIS. This is a name, not name of a satellite, but the name of a camera installed in a few different satellites, at least in 2 different ones. And these property satellites, these are the most frequently flag shooting satellites, which have the shortest shortest revisit time. The revisit time for Sentinel-2 is usually 5 days for 2 satellites. For Landsat 7, 8, and 9 is 16 days for each of them. And finally, the data availability. Actually, every satellite is available for a certain period. It was or still is operational. It has been operational for the orbit. For example, the Sentinel-2 images are very useful, but they are only available since July 2015. And here in Sentinel Hub is mainly available since 2016, basically. The MODIS data from at least 2 satellites were available since January 2013, and in some other data were available from other sources were available since 1999, but not on that portal. Landsat series satellites, they have the longest history. This is very important to understand. But if you would like to go deep in time back with Sentinel Hub, then Landsat has virtually no alternative. They started being available since mid-1980s, and at Corsair scale, if you are talking about this Landsat 1 to 5 MSS camera, then even since mid-1970s. So for about last 50 years already. So that's a very long history, and there's a picture in the bottom of the slide. You could see the years, the time periods available for different Landsat series satellites, and you see that right now there are 3 Landsat 7, 8, and 9 operational in orbit. Right now, it means the summer of 2022. This is just an example how deep we could go and how we could use the various satellites to monitor the fire history. For example, in Eastern Siberia, this is one of the area in Yakutia, pretty far north, the remote areas where it is impossible to monitor forest fires any other way other than with satellites, basically. And using this Sentinel Hub, you could just access an imagery and start to see the history. This is the location of the area we're going to monitor, and I will just briefly show you the gallery of pictures saved from Sentinel Hub since 2010. And in 2010, there have been no forest fires, large forest fires in the area. But in 2011, in May, you could see no new forest fires, but in June already happened. And this was the only forest fires over 2011. And yeah, yet another one in August. And yet another one in September. So in 2012, there have been no forest fires at all, but in 2013, we could detect some new. And in another year, we will have another 4 pretty large forest fires in the area. And in the beginning of 2015, we could see the fire scars, the footprint of a fire. In that early spring image, you could even see some snow on the top of the mountains, but you could also see the tracked scars after fire for the previous year. And in 2015, some before July, there have been no fires, but later on, in September, we also could check there is no new fire scars. But in 2016, we could also see a few images over the year, and in 2017, some new fires started in August, and we could see like smoke, and the image was done while burning the area. And you can see the scars of fires for 2017. So a few of them. And in 2018, you could then see some new fires. 19, especially that year, has been for the area. A few large forest fires happened. Started since June and continued in July. You can see just the same area was burning larger and larger in size. So you see that big forest fires could continue for weeks, if not for months. Sometimes it is still the same forest fire, and only in the September it finally ended. You can see the fire spark here, and in the year 2020, we also could see a few forest fires just going on while shooting. And just a few weeks ago, you could see just expanded area. And now you see a lot of smokes here in the area. You can see a lot of burning areas, and in the autumn you could see the fire scars left after the fires. And also many smaller ones. And also in the year last year, in the year 2021, you could also see a number of new fire scars appear, which are very well visible, and you could see new ones over. And in the midsummer, you could see plenty of ongoing forest fires in the area. So this is all new, just in 1 year, even half of summer of 2021, future as well. So you also could see some scars of the previous year, but it is just freshly done. So this is how different various satellite images, and you probably notified that this is Landsat 5, Landsat 7, Landsat 8, Sentinel 2 over more than 10 years. And you could use all these images to monitor the fires. And finally, when we are choosing satellite images to search via Sentinel Hub, we also should remember about the specific type of satellites, where most of the satellites we have discussed so far are optical satellites, so working at recording the light, the visible light and infrared light, but there are also some satellites which are equipped with radar, and they are actively sending the radio waves to the Earth and somehow recorded the reflectance of these radio waves and working in that diapason of electromagnetic spectrum. And these radar images, they look completely differently from the optical images. For example, this is the area in Western Siberia, in the oil field. You will see some metal equipment for oil pumping, for keeping oil. You can see the reservoir is oil, for example, here, which are metallic, and they do reflect radio waves very well, and so you can see them white, very bright and fit images. And the water is opposite; it consumes radio waves, so scatters them, and so the water surface are seen just black and white image. But also the interesting the radio waves, they are more sensitive, of course, not to the somehow not to the color of the surface, but on the shape of the surface. Even it could be reflected differently from the sea surface if they have different waves on it. And this is particularly why you could see the oil spills on sea that could be detected with radar images, because the oil on the surface of the sea, it changes the shape of the waves. And so you could see these areas as these more dark spots over the sea surface. And this was the particle oils detected with radar satellite images in the Black Sea. That's also another application of radar satellites, radar imagery. You could monitor the sea ice, also a movement of the sea ice in the polar seas. And also you could see the ships. For example, here on the left side, you could see the icebreaker and a few ships following it in the White Sea in the northern Russia. And in the image in the right lower corner, you could see the overview picture for the whole White Sea. And what's important that for radar waves, the clouds are transparent. So you could, with radar satellites, you could monitor the areas even during the bad season, bad weather, when everything is covered with clouds and optical satellites are useless. But the radar satellites could be employed for monitoring in that case. Also, you could just somehow, because radio waves were sensitive to the shape of the area, you could use the radar satellites to map the elevation and to build the digital elevation model. Like for example, this compact mountain area. You could see the relief very well, and it could be used for that. But actually, the radar images, the most of radar images are available only for commercial purposes, money. There is the only satellite called Sentinel-1, which is available for free. With Sentinel-1 imagery, you could see, you could study in the Sentinel Hub, your browser, and they are also available here. And this is a unique case where radar images are freely available. Thank you. That was a brief overview of key characteristics of key features of a satellite imagery and a brief guidance of which satellites to use in the Sentinel Hub for what purposes. Please keep all of this in mind: the spatial resolution, the revisit time or temporal resolution, and the period of availability, for which years we have which satellites operational. Thank you.